Hello everyone, I am Ms. Megha Karwal, Department of Civil Engineering from Praveen Patil College of Diploma Engineering and Technology, Biden. Welcome to all of you in today's lecture. In today's lecture, we are going to start chapter number 5, Construction and Maintenance of Tunnel. This is a content of our 5th chapter, Tunnel Engineering. It is a branch of civil engineering deals with the design, construction and maintenance of tunnel. Definition of tunnels. The underground passages which are constructed without disturbing or removing the ground surface are known as a tunnel. They may be constructed by cutting the hills or mountains below the ground, stream, etc. for various purposes. Uses of tunnels. They are used for transportation of means, materials and goods. They are used for carrying waters, oil, sewage, gases, etc. They are used for conduction of water to generate power, in which cases they are known as hydropower tunnels. They are used to provide access to mines. Necessity of tunnels. When the terminal stations separated by mountain are to be connected by shortest route, when there is a necessity of carrying water, oil, gas, etc. across a stream or mountain economical. When the surface route of railway track or road for reaching the other side of hill is much longer and therefore costlier in construction than a tunnel. Advantages of tunnel: connect the terminal station by the shortest route. They facilitate less route length and thus result in the less transportation cost. They carry railway lines, roads and public utilities like water, oil, gas, etc. cross stream or mountains economically. They provide protection to the railway track or road pavements from the effects of the rain and other weathering effect. Disadvantages of tunnels: they require skilled labor and supervision in their construction. They require special equipments and method of construction. They require more time in their construction. They may cause suffocation if not properly ventilated. Next is the classification of tunnel. Tunnels are generally classified on the basis of purpose, according to type of materials, according to position of alignment. So let's start with first type is classification of tunnels according to the purposes for which they are constructed. So first type is traffic tunnels. They are classified as railway tunnels, highway tunnels, navigation tunnels, subway tunnels and pedestrian tunnels. Second is according to the convenience. So they are classified as a water supply tunnel, hydropower supply tunnels, sewage tunnel, tunnels for industrial uses, tunnels for intake and convenience public utilities. Third is according to the materials. They are classified as tunnels in hard rock, tunnels in a soft rock, tunnels in a quicksand, tunnels under river bed, open cut tunnels. And third type is according to position of alignment. So first they are classified as first is saddle and base type tunnel, spiral tunnel, obspur tunnels and slope tunnels. Shape and size of tunnels. Various shapes of cross section may be adopted for tunnels, the deciding factors being the nature of the soil through which the tunnels is driven and certain practical consideration. The shape of a tunnel is represented by the section profile. So following are the usual cross section or the shapes of tunnels are commonly adopted. So first is rectangular tunnel. This type of tunnels are suitable for pedestrian tunnels, and the tunnels of this shape are rarely used these days because they are difficult in a construction. Second type is segmental shape tunnel. The tunnels of these shapes are suitable for traffic tunnel. They are used in a subway or as a navigation tunnel. They are also known as a D-shaped tunnels, and they are difficult in a construct in a soft rock. Third type is circular tunnel. These tunnels are commonly used for carrying water under the pressure. They are suitable in non-cohesive soil. The lining of these tunnels are very difficult. Fourth type is horseshoe shaped tunnel. These tunnels are suitable in a soft rock. They are having a combination advantages of circular and segmental shape of tunnel. They are more difficult to construct, having a semicircular roof with the arch side, and it is commonly used in a railway and roadway. Next is egg-shaped tunnel. These tunnels are widely used as a sewer. The tunnels with this shape maintain self-cleansing velocity, and they are difficult to construct. This shape have a smaller cross section at the bottom. Egg-shaped type of tunnels are best suited for sewage line. Okay, and if egg-shaped tunnel can resist the both internal and external pressure. Difficult to construct and not suitable for traffic tunnels. Sixth type is elliptical shaped tunnels. These tunnels are suitable for carrying water. They can be easily constructed in a soft rocks. Lining of these tunnels is difficult. Elliptical shaped tunnels have the advantages for the transportation of sewage. The smaller cross section at the bottom maintains the flow at the required slip cleaning velocity. However, due to the difficulty in the construction in a circular shape, ones are more common. Size of tunnel. The size of tunnels is determined by its utility for irrigation purposes. The tunnels is generally designed to run full, and if lining is of concrete, the velocity is taken as a 366 cm per second. In case of the road tunnels, it will be depends number of traffic lanes, and in case of the railway tunnels, it will be depends on the number of lines and type of gauge. Factors affecting the size of tunnels: volume and type of traffic, the size of clear opening required, the thickness and allowance of the lining, drainage facility required. Volume and type of traffic. The total volume and type of traffic, including the size and speed of the vehicles to be handled, will govern in the size of tunnels. The size of clear opening required in case of the railway tunnels of a single track, a clear space at least 75-60 meter on each side should be allowed between the tunnel wall and the side of the largest locomotive. The thickness of the lining is varies with the material, so the to be penetrated in a lining to allowance is 5 to 7.5 cm for inward movement of side walls without endangering their stability should be given. The type of drainage system to be also affect the size of tunnels. Tunnel cross section for highway and railway. The construction of tunnels is costly. Therefore, only minimum dimension required should be adopted. This dimension should be convenient not only for the actual movement of the traffic but also maintenance work of the communication route. So, if the vehicle carriage provide with the doors opening outside, it is essential to have some clear space of the door when the open to prevent accident. The cross section of tunnel showing the dimension for a two-lane highway is shown in a figure, and the figure number 1, and the cross section of tunnel showing the dimension of this single broad gauge railway track is given in a figure number 2. Of it, tunnels involves the following operation. First is locating center line on the ground. After deciding the routes for the tunnel, its center line is accurately set out on the hills or ground by means of common theodolite on a calm and clear day when the length of the tunnel is short. If the tunnel is long and constructed under the high maintenance, the alignment is set out by the triangulation preferably with the help of micrometer transit theodolite. The alignment is then finally set out by permanent monuments of stone or concrete. The position of such a permanent monument should be located by taking offset from the nearby permanent structure for controlling or checking the alignment till the tunnel project is completed. Next is construction of the shaft over the center line. This is a shaft. Okay. So after setting out the alignment on the ground, shafts are constructed at suitable interval for the transferring the center line to inside the tunnel. Transferring the center line inside the tunnel. After constructing the shaft, the center line of the tunnel is to be transferred down to the shaft. For this purpose, generally two small pillars are constructed opposite edges of the shaft along the center line of the tunnel. On the top of this pillar, the points corresponding the center line are correctly marked and wire is then stretched between them. After this, two plumb bobs are suspended by piano wires inside the shaft. 2 points are then marked by lowering the plumb bob to the bottom of the shaft. The line joining these 2 points represented the center line of the tunnel marked on the ground. This line feature extended into the tunnel heading as the work is advanced by theodolite placed in the line is further extended into the tunnel heading as the work is advanced by a theodolite placed in the shaft. Points along the center lines are marked by peg provided with the plumb bobs fixed to the roof of the tunnel as shown in the figure. By preventing oscillation or vibration, hanging wires having a plumb bobs are used and kept immersed in the pot containing oil which is placed on the floor of the shaft. Shaft. When the length of the tunnels is small, it can be constructed by excavation work from one side. But in case of the considerable length and to complete the construction work in a short time, the excavation can be done from both the ends of the tunnels at the same time. The vertical opening or a passage or a well constructed along the alignment of the tunnels are known as a shaft. Purpose of the shaft: to start the excavation from the work from both the sides to avoid delay in the construction, to provide natural ventilation during the construction of work, to provide opening for removal of excavation material, to provide passageway for construction tools, machineries, posting of mugs, pipes for ventilation, compressed air and water supply, to transfer the center line inside the tunnel. These are the purposes of shaft. Construction of shaft. Following are the main operations for the construction of the shaft in the rocks. In a special cases, however, the shafts can be constructed from the tunnels in upward direction. The construction of the shaft in upward direction is cheaper as the muck is dropping down and can directly tapered into the muck carrying cars. So first step is drilling and blasting, second step is mucking, third step is timbering, and fourth and last step is a pumping. Drilling and blasting means holes are drilled in the rocks by various drilling machines and equipment such as the jackhammers and pneumatic compressed air operator equipment. The large size of shafts are excavated by steep down technique for permitting the drilling operation and taking out the mucking outside the simultaneously. Mucking, the operation of removing the excavated material of the shaft and dumping the sum at a predetermined site is known as a mucking. Mucking is done by the manually mechanically. Timbering. It is a process of providing the temporary support to the cut soil sides against the falling till lining is done or finally fill up after the completion of the work. The arrangement of the timbering varies with the types of ground and depth of the shaft. Pumping. Usually, pump sets used for lifting the water from the shaft. This water may be due to seepage from the underground or waste water used during construction operation. In the beginning, the bucket used for removing the muck can be utilized in a lifting up the water also. In case of deep shafts, it is very costly to pump the underground seepage water. Advantages of shafts: they help to correct alignment and help to carry the center line into the tunnel proper. They afford the outlet for the excavated materials and means of access into the tunnel for building material. In long tunnels, the afford ventilation are useful for existing smoke out of the tunnel. Thank you.